Okay, this is going to be a quick ellipse review. So here are the formulas you need for a horizontal ellipse. Uh, these are the formulas you need for a vertical ellipse. So if you don't have those written down, please write those down. Again, you can use a formula sheet for your test for this chapter for me. So here's an example of one. This may not look like an ellipse. If you look at that ellipse equation, it's supposed to be equal to 1, and that equation clearly is not equal to 1. And so if you remember doing this, you've got to divide by whatever this term is over here, in this case 27. Divide by 27 for each of those and simplify. 9 over 27 is 1/3, so x squared over 3. Sorry, x squared over 3. X squared over 3 plus 3 divided by 27 is 9, so y squared over 9 equals 1. So we have our ellipse. So that's our ellipse equation. The center for all these ellipses so far have been 0, 0. Eventually we'll get there where we'll have something bigger. So if you see that according to the formula, A is always bigger than B, and it looks like the bigger number here is 9 here. So this must be a vertical ellipse. In other words, this one must be equal to A squared. So A is equal to 3. And then this one must be equal to B squared. So B would have to equal the square root of 3. So underneath y is always vertical distance. Just like here, so this distance from A vertex to the center is A. So I'm going to go basically vertically 1, 2, 3 up and 3 down because that distance A is equal to 3. So I'm going 3 up and 3 down. The total, it's called the focal, it's called the major axis. The total distance there is 2A from red point to red point. Those are the vertices of this ellipse. And the co-vertices would be square root of 3 over. Square root of 3 is more than 1 but less than 2, so 1 point something. So 1 point something over here, at 1 point something to the left and to the right. Those are co-vertices. So those are co-vertices. And we go and graph the ellipse now. Go through each of those points. Looks something like that. You might want to put those ordered pairs would be square root of 3, comma 0, and that's negative square root of 3, comma 0. They're in a nice vertice like a lattice point, you're okay. Again, if you're having trouble, use the formulas. So the formula is 0 plus or minus a. So if you knew a was 3, square root of 3, then that's I guess those are the co-vertices there. So I don't have a formula for the co-vertices, but it would be plus or minus b comma 0 would be the co-vertices. And given these situations, so we have a vertice of 0, 5, 1, 2, 3, 4, 5. That's a vertice, and 1, 2, 3, 4, 5. We have a focus point at 0, 4, 0, negative 4. So we have to come up with the equation. We might even want to draw this. So right away, you should hopefully figure out that a is equal to 5 here. It's definitely a vertical ellipse, and there's a distance of 5 from the vertex to the center. C is the distance from the focus to the center. C is equal to 4. And we just don't know what B is, so we've got to figure out B. And we do know a formula, if you remember, if you look at the formula sheet. So A squared equals C squared minus B squared for an ellipse. So this will be A squared is 25. I'm sorry, that's not the right formula. Takes a while. So there's a little different formula. I believe it's actually C squared equals A squared minus B squared. That looks a little better there. You got to remember your formulas. That is one of your formulas. If you look back at your formula sheet, there it is. right there, c squared is a squared minus b squared. That's true for both horizontal and vertical ellipses. So this will be 16 equals 25 minus b squared. So you could do a number of things. I'm going to add b squared both sides. I'm going to subtract 16. I get 9 here, so b equals 3. Remember, b is always positive. So b is 3 here, so I'm going to go 3 units to the right and 3 units to the left. Make that point. Looks roughly like that. B is 3. So now we have our formula. It's going to be x squared plus y squared plus 1. Underneath y is this vertical distance, which is 1, 2, 3, 4, 5, so 25. Horizontal distance is 3, so that's 9. You'd square that. So that's just your a squared underneath y, your b squared underneath x, because this is a vertical ellipse. This is just given information focused on the y-axis. Major axis is 9, and the origin is center. So here's our center. The major axis is 9, so that's 4.5 vertically, because the focus is on the major axis here. So 1, 2, 3, 4, 4.5, and 1, 2, 3, 4.5, right about there. The minor axis is 6, which means I go 3 units in each direction. And you can draw your ellipse. And so we need to figure out like some of the values here, like this distance from here to here is going to be A, which is 4.5. And this distance from here to here is B, and that looks like it's equal to 3. So we know our A and our B. We can certainly probably write our equation at this point. X squared over something plus y squared over something equals 1. Vertically, we're going up 4.5. I might write it this way. You could write it this way, 9 halves squared or 81 fourths. Here would be 3 squared or 9. Just write it, keeping it in that form. Either way is fine with me to write it. And then if you wanted to graph it, I know this was just probably like write the equation, but if you wanted to graph it, you would have to use the formula c squared equals a squared minus b squared. So in this case, that would be, let's see, a squared would be 9 half squared, which is c squared equals 81 fourths minus 9, which is 36 fourths. So c squared equals, wow, 45 fourths, I think. I did that right. And so c would equal the square root of 45 fourths, or square root of 45 divided by 2. So you get that approximation and find out exactly where that value is. Probably somewhere around 4 is my guess there, but I'm not exactly sure. So you've got, so that's how you could graph the, find the focus points and graph those if you needed to, but your equation is this one. And finally, this is an easy one. Just start writing your equation, x squared plus something, y squared over something equals 1. Vertically looks like that value is 2, so there'll be 4 underneath y. Horizontally is always underneath x, so that's 1, 2, 3, 4, 5, so this would be 25. This is definitely a horizontal ellipse. This one is equal to a squared, if you didn't realize that, and this one is equal to b squared. So a is really 5 there, b is really 2. Again, I'm just looking at y is always vertical, so underneath y is vertical movement, so it goes up and down 2, so that's going to be 2 squared or 4. X is horizontal movement, it's going right and left 5, so that's going to be that value squared, which is 25. And that's basically just a quick review. Hopefully you're ready to take your quiz now on ellipses before we get to the rest of the chapter.